So in this example, we're going to consider the following function, consider the following graph, and we're going to attempt to determine a function. So the graph is, as you can see here. Now, when it comes to sinusoidal curves, there are three aspects that you cannot control, and there are three aspects that you can control. Ultimately, we are looking for one of the following two. Y is equal to a times the sine of omega x minus phi plus b, or y is equal to a times the cosine of omega x minus phi plus b. The three things that you cannot control are the midline, the amplitude, and the period. So let's calculate those first so that we get a good idea of what's going on. You'll notice that the maximum value is positive 5, and the minimum value is negative 5. The midline should be exactly halfway in between those. That'll be y is equal to 0, which lets you know that the value of b associated with this graph will be 0. The amplitude is going to be the vertical distance from that midline to a maximum, or from the midline to a minimum. And in either of those cases, that distance is going to be the 5 that we see indicated on the y-axis. This lets me know that there are going to be two possible values for a, and the two possible values for a are positive 5 and negative 5, depending on whether or not there's been a reflection. And finally, the period is the horizontal distance between a maximum and a maximum, or a minimum and a minimum. I'm going to go from minimum to minimum in this case because those are both indicated very nicely. We're going from x equals 0 to x equals 8 pi. That means that the period is going to be 8 pi. That also means that I can evaluate the value of omega, which is going to be 2 pi divided by the period, which we just calculated to be 8 pi, letting me know that my value of omega is going to be 1/4. Now, the three things that you can control. The three things that you can control is which mother function we're using, whether it's a sine or a cosine, whether a is positive or negative, and we can control the value of phi by selecting a starting point for one period that's not necessarily going to be x equals 0. Let's assume for a moment that we are simply going to use x equals 0 as our starting point. So this is the starting point, also known as the phase shift. Now if we're going with x equals 0, then the phase shift is supposed to be equal to phi divided by omega. At this point it doesn't really matter what omega is because we're going to have phi is equal to the phase shift times omega. Well, that's 0 times omega, so that's going to be 0. So there is no phase shift. You'll also notice that at x equals 0, we are at a local minimum. Local minimum tells us two things. The fact that we're starting at a local something means that our mother function is going to be the cosine of x. Now normally the cosine of x starts its first period at a maximum. The fact that we're at a minimum means that there has been a reflection. I want an a value that's negative. So when we put this all together, that means that we'll be dealing with y is equal to a, which I now know I want the negative version of that. So negative 5 times the cosine of omega x, omega we got right here, omega x minus phi plus b. If I got this as a final answer, I would be happy as a clam. However, that's not the only way that we could do something like this. You are allowed to pick any starting point that is either a midline point or a local maximum or local minimum. Now, for the example that we just did, we got that the mother function was the cosine, and we got that a was negative. I want to do the opposite of those two things, meaning that I would like to have a sine curve, and I would like to use a positive value. Now for a sine curve with a positive coefficient, we would want midline and increasing. There are a couple different points where that takes place on our graph. I'm going to pick this one right here. I'd like to use a starting point of 2 pi. So what we're saying is that 2 pi is equal to phi over omega. Starting point and phase shift are synonymous. Now, solving this for phi, we get phi is equal to 2 pi times omega. Then we'll actually plug in the value of omega, which is 1/4, and we'll get that phi is equal to pi over 2. The point where we decided to start is midline and increasing. Midline lets me know it's going to be y is equal to the sine of x for the mother function. Increasing means that a is going to be greater than 0. Putting all of these aspects together, that lets me know y is equal to a, we'll be using positive 5 this time, times the sine of omega x minus phi plus b. Once again, b is equal to 0. So this would be another form of a correct answer for this function. Now, depending on whether you start at a local minimum or local maximum, midline increasing or midline decreasing, there are lots of different ways that you can express a correct final answer.